Hello there, 10Cs. Hope everyone is well as we get ready for our next lesson. Today we're going to talk perfect squares, perfect cubes, and their roots. Again, before we get into the polynomial stuff, this is a little bit of background information, terminology. Some of it's new, some of it's review. So follow along and we'll make the best of it. The only thing I want to remind you as we start, don't just write down and copy what I'm putting. If I put an example up, pause the recording, try the question on your own. We're working through the textbook, the booklet, so do the work yourself. Make sure you understand it instead of just copying down what I've put and said, oh yeah, I get it, because chances are, yeah, maybe you don't get it. So what we're looking at today is we are looking at perfect squares, perfect cubes, and their roots. So we've seen perfect squares before quite a bit. A perfect square is a product, a multiplication answer created by multiplying a number times itself. So this isn't a new concept. A perfect square that's a product could be something like 25. 25 is the product of multiplying a number times itself. Now, what you have to be careful of is terminology, though. 25 is the perfect square, but you have to understand close terminology is the square root value. 5 is the square root value of the perfect square. So, common information, common sounding terms, but very different. If I wanted a perfect square, 16 is the perfect square, but 4, because 4 times 4, that would be the square root value. So understand the difference between those two things. Not a big difference, but significantly different in what they represent. So with perfect squares, it's any number, again, instead of saying it's a perfect square, it's also what I refer to as number that is square rootable to a whole. So if you can think of a number, not necessarily a whole, but a better term would be a terminating value. So if I wanted another perfect square, well, another perfect square would be 36. Now with 36, what we can do with that is we can actually square root it. And that's the little symbol we've seen before, square root of 36. This is asking us to find the number that you multiply by itself to get that product of 36. So if we start with 36 and we square root it, we get the square root value of 6. Now you have to be careful. We're going to have to memorize some, but at the same time, there are certain situations you need to be aware of. Popular one would be something like square root of -9. Well, a lot of people say, oh, well, that's going to be -3. But it isn't, because a square root is asking for the number multiplied by itself. And this is where we have to be careful. There is no number that if I start with -9, something times itself. It doesn't exist. The only way to get a negative is to have a negative times a positive, different signs. This obviously isn't something times itself because there's different signs. So the square root of -9 isn't -3. It's impossible. Until you get to higher level mathematics. And then you have imaginary numbers. But that's for university, maybe high school if you get into calculus. However, we do not square root a negative number. It can't be done. So be aware of questions like that. Now, we are going to use perfect squares this unit, but more importantly, next unit, you really should eventually have the first 15 perfect squares memorized. My suggestion is We're going to write them down, make a cheat sheet for yourself for quick access. This unit really should be attempted without a calculator. Having a cheat sheet with perfect squares could be useful. So 1 squared is 1. 1 times 1. There's your first perfect square. The next perfect square would be 2 squared, which is 4. 3 squared, which is 9. Most of these, if you know your times table, which you have been warned about for several months now to be able to do, you should know these perfect square values. 1, 4, 9, 16, 25, 36, 49. And if we finish it off. Now, last year, some of your grade 9 teachers expected you to know perfect squares up to a certain value. So these, if you don't know them, really you should. 64 is the next perfect square. 81, 100, 121, 144, 169, 196, and 225. Those perfect squares, you really should understand that they're perfect squares, and you should understand and be able to recall those. No problems, no questions asked. Make yourself a cheat sheet, have it available, because knowing those 15 perfect squares is going to be important and an expectation I have. The next part is something you may or may not be familiar with, and that's a perfect cube. It's the same kind of idea, the product created by multiplying a number times itself 2 times. So what happens, it's cubed because the number is a factor 3 times, cubed. So if I took 2 times 2 times 2, well, there's a number times itself twice. It's a factor 3 times, and that equals 8. So 8 is considered not a perfect square, but a perfect cube. And again, what's true? The value you multiply by, it's the cubed root value. So 8 is the perfect cube, but 2 is the cube root value. Terminology you have to be able to distinguish between. Now with perfect cubes, it's a little interesting because if we start with 64 and I want to know what do I multiply 3 times to get 64, well, what we're looking for isn't the square root of 64, but we put a 3 out front. This 3 is telling us it's a cube root value. What are you multiplying 3 times? A little bit different. When we have square roots of things, if I want the square root of 100, what times itself equals 100? Well, that's 10. The 2, we don't put that little 2 out front. It's just assumed to be there for square roots. But any other kind of root, we need to include, and this is referred to as the index. So we want to know, what do we multiply 3 times to get 64? Well, 4 times 4 times 4 is 64, because 4 times 4 is 16. 16 times 4 gives you 64. So the cube root of 64 is 4. Now, what you have to be careful of now is cube rooting a negative number. Square rooting a negative, we just showed you, can't be done. But cube rooting a negative can be done, because I want to multiply something twice, 3 times it's a factor, and in order to get a negative, I can multiply a negative times a negative times a negative to equal a negative value. How do I get a 125? 5 times 5 is 25, times another 5 is 125. And negative times negative times negative gives us negative 125. So we can cube root negative values. What do we multiply 3 times to get negative 8? A negative 2. So we can cube root negatives, but we can't square root negatives. Same concept, a little bit of a twist. Now, the 10 perfect cubes, again, that's something you should get to know. Are you going to know them as well as perfect squares? Probably not. But having this as part of your cheat sheet for quick reference. Doing this unit without a calculator, it's a great skill. You need to be able to recall a lot of these. So in this case, 1 cubed, 1 times 1 times 1. 1 is our first perfect cube. 2 cubed, 2 times 2 times 2. Well, that's 8. And we can just continue this to get 10 perfect cubes. Oh, cubed, not to the 5th. 5 cubed is 125. And now we go to 6 cubed, 7 cubed, 8 cubed, 9 cubed, 10 cubed. These are all values you should have written down, access to, because you will be expected to know these. 6 cubed, 6 times 6 times 6, 216. 7 cubed, 343. 8 cubed, 512. 9 cubed, 729. And 10 cubed is 1,000. So what are the first 10 perfect cubes? 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000, because all of these values are cube rootable. We can cube root all of those to give a whole number. You need to be familiar with them. So, real quick background, a little bit of terminology. You need to be familiar with it. So here you go, 6 questions. Do them quickly. What are the square roots or cube roots for each question? These should be on your list, should be able to come up with them fairly quickly. 11, 9, negative 14, 4, cube root of 729. Now we're getting trickier. 9, cube root of negative 125, negative 5. At this point, I'm really hoping several of you have stopped and said, wait a second, this goes against what you just said, Mr. McDonald. And that's the fact here. We cannot square root a negative. Negative 14 times negative 14 is positive 196. We cannot square root a negative, so it's not possible. Everything else is okay except for that one. You need to be familiar with these. Now, with that being said, if we want to square root something, there aren't a lot of perfect squares considering the number of numbers in the number world. We said the perfect squares, 1, 4, 9, 16, 25, 36, and so on. There's lots of numbers in between here that we haven't dealt with. That's why we should be able to estimate square root values. Estimating is just that, an educated guess. So, what's important to estimate a square root? The first thing is, what are the perfect squares that the number falls between? So if I think of a number line, what are the perfect squares that 85 falls between? Well, hopefully you understand we have 81 and we have 100. 85, if I sort of estimate about where it would be between this, there's 85. Now the reason we need these perfect squares is because if I think the square root of 81 is 9, and I think the square root of 100, well, that's 10, right away, the square root of 85 has to be somewhere between there. So we know it's going to be 9 decimal something. So the perfect squares that it falls between give us our start to our estimate. Now the second part is to identify how far from the perfect squares we are. So in this case, 81 to 85 is 4. 85 to 100 is 15. Well, this is where the educated guess comes in. Now estimate the closeness to the perfect squares. So this is an educated guess. We see we're 4 away from 81, but 15 away from 100. So we're way closer to the 9 than the 10. So we know that our estimate, because we're so much closer, we're closer on that end, this number is going to be a 1, a 2, a 3, or a 4. If it was right in the middle, let's say that we do this and we see that our number is right in the middle. Let's just say it was a 12 and a 12 away. Well, our estimate would be 0.5 because it's right in the middle of our two perfect squares. But it's not. We're much closer to the 9 than the 10, so we know it has to be something less than half. Now this is where the educated guess comes in. We're not really towards the middle, so we're not around 4. It's significantly closer to this end, so it's probably not 3. So 9.1 or 9.2 would be a good educated guess. Identify the perfect squares. That's your first step, 81 and 100. Identify how far apart they are. Well, you're 4 away here, but you're 15 away here. Estimate. Much closer to the 9, so we're going to be a 1, 2, 3, or 4, but it's significantly closer. It's not in the middle-ish. 9.2, 9.1 would be a good educated guess. So, try to estimate the square root of 130. How do we know it's not, or it's going to be an estimate and not a calculate? Well, because we know 130 isn't a perfect square. What's the first thing? What are the perfect squares that it falls between? Well, 130 is between 121 and 144. Know your perfect squares. 130 is somewhere between those. We know that 121 is 11 square rooted. We know 144 is 12 square rooted. So therefore, we know the square root of 130 is somewhere between there, 11 decimal something. Second thing, how far apart? So these two numbers that we come up with here we can see we're 9 away, here we can see we're 14 away. These two numbers aren't our estimates, but they just help us get an idea how far apart they are. And again, we are closer because we're 9 away as opposed to 14, so we know we're closer to 11, so our estimate's going to have to be a 1, 2, 3, or 4. So now we make the estimate. In this case, I see we're 9 away and we're 14 away. We're not really close to the 11, so I can take away the 1 and the 2. I would say we're not right in the middle either. We're not totally middle-ish. So I'd take away the 4. 11.3 is a good estimate. Square root of 130 is approximately, an equal sign with a dot means approximately. We are approximately at 11.3. So 11.3 times 11.3 would be very close to 130. So square roots. Now, here's a big calculation. If we didn't have a square root or perfect or cube root on our calculator, we can use prime factorization, which we talked about last lesson, in order to figure out if we have a perfect square or a perfect cube. The first thing is to prime factorize the value. Remember, that's a factor tree. So we want 4,096. 4,096 in a factor tree. Well, it's going to take a little bit of time, but can it be done? Absolutely, it can be done. So here we go. 4,096 ends in an even number, so we know it's going to be multiplied by 2. What does that leave us with? It leaves us with 2,048. Well, remember 2 is prime. We can't break it down, so it just comes down. But now we want 2,048. Again, even numbers, so we know it's 2 times something. In this case, it's 2 times 1,024. Factor it down. Prime numbers just are brought down. 1,024 is a composite number. Even number again, so it could be 2 times. In this case, it's 512. Keep going from there. We are just going to keep factor treeing until we get to just prime numbers. And we just keep breaking it down as much as we can. Keep going. 256, 128. Keep going from there. Now we're getting to something a little smaller, getting close to the final value. Prime factorized form. This thing is huge. Well, 64, we know could be 8 times 8. 2 times 2 times 2. This is a monster of a prime factorized form. 4 times 2 and 4 times 2. And now, last one. 2 times 2 times 2 times 2 times 2 times 2 times. The 4 is 2 times 2. Bring down that 2. Times 2 times 2. And bring down that last 2. Wow. So 4,096 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 twos, which we could write out as 2 times 2 12 times. Remember though, 12 twos could be written as a power 2 to the 12. So there's your factor tree, big and long. Great review of it though. So how does this help us? We know that 4,096 is, and I'm going to write it out to 12 times. What do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, if I want to square root 4,096, I need something times itself. Well, in this case, because there are 12 2's, I could have 2 to the 6, which is 6 2's, times 6 more 2's. So 4,096 is 2 times 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 2. So the square root of 4,096 is really 2 to the 6, which equals 64. So 4,096 is 64. Because a perfect square can have the factors split into 2 groups. That's the key. If you can take all of your 2's, all of your factors, and split it evenly into 2 groups, there's the factored form, which gives you your square root value. So that's how you can square root. Well, we're going to do something very similar for the cube root. But for the cube root, if you think of it, we need what for a cube root? We need 3 groups of factors. Well, if I again have 12 2's, can I make 3 groups of 12 2's? Absolutely I can. I could go 2 times 2 times 2 times 2. There's 4 of the 2's times 2 times 2 times 2 times 2. There's 4 more, 8 of the 2's times 2 times 2 times 2 times 2. So this is saying 2 to the 4 times 2 to the 4 times 2 to the 4. There's my 3 factors. 2 to the 4 is 2 times 2 is 4 times 2 is 8. We have 16 times 16 times 16. Because I could take all my 2's and evenly split them into 3 equal groups. So the cube root of 4,096 is 16. So prime factorization, once we get it to our prime factorized form, we can tell if we have perfect square or a perfect cube. Because a perfect cube, factors make 3 equal groups. So square roots and cube roots. Yes, the calculator's handy. We can do this work on the calculator, but having the knowledge without is important. If I pulled up a calculator and let me get rid of what I was doing yesterday. If I have my calculator, we can hit, if you look on your calculator, above the x squared button on the left side is the square root. Second function, x squared, that is going to give us a square root sign, which I can now punch in my 4,096, hit enter, and we see the square root of 4,096 is 64, which we figured. But the cube root's a little different. If you again look at the left side, under the second function button, 2 down, is a math button. You want to hit the math button. If you look at the math button, point number 4, if we scroll down to 4, that's saying, hey, we want the cube root. If I do the cube root of 4,096, there's our value of 16. So yes, the calculator has the ability to do this, but you really should also have some knowledge of the fact that the prime factors can help you come up with that. So, last little bit. Here we go. This has been a long lesson. Real-world applications of perfect squares and perfect cubes. Real-world applications of perfect squares and perfect cubes. Well, there's 2 situations essentially. For perfect squares, what we're looking at is any kind of situation that involves the area of a square. For perfect squares, the area of a square is where we could square root. For whatever situation, you have an area equal to 25. Well, because it's a square, we know the area of a square is side times itself. Well, how do I figure out something times itself? I square root the area, and that'll equal a side. Square root of 25 is 5. So we know the sides are 5 units wide. Anytime you have a square, and it's all about the fact that it's a square. If our area here, nice and easy, was 81 meters squared, well, that would be side times side. They're the same. So if I square rooted the 81, that would be the side length, because the square root of 81 is 9. So each side would be 9 meters wide. A perfect cube, when would a perfect cube have a real world application? Well, it's if you're dealing with volume of a cube. And again, it has to be cubes, and for perfect squares, squares, because the whole point is sides are the same. If you have a cube, and we know the volume is 125 centimeters squared, well, that means volume is length times width times height. Well, length, width, and height, because it's a cube, these are all the same. So that means our volume is side times a side times a side, because these in a cube will all be the same. So if I cube root 125, what do you multiply by itself to get 3 times to get 125? Well, that would be 5. So 5 centimeters would be the side length. So cube roots deal with volume of a cube. Square roots deal with areas of a square. So keep those in mind as you work through the assignments. In terms of the assignments, there's some textbook work. Again, without a calculator. Try, have some scrap paper, practice your division skills. Pull out your phones. Practice your basic facts. You are going to need your basic facts moving forward. Have fun with it. Get some work done.